So we can start.
Yes, I guess that you can start here.
Hello everyone. Welcome to this new seminar from our series of suite webinars. Today, the focus will be on health impact of transport modes and its role on our transport choices. Helene Bouscasse and Rejeb, researchers at CESAER and respectively GAEL laboratories, have been working since a few years now, if I'm not wrong, on this topic within the interdisciplinary project Mobil'Air. We thank them for having accepted our invitation to share with us some insights and main results from this common work. There will be about 45 minutes of presentation. You can address your questions, your comments or remarks by writing them progressively in the section Q&R on the screen. You can see it, and I will read the questions for you. Of course, if your questions are important to ensure full understanding, I will interrupt the presentation in order to get additional explanation. Otherwise, for more general comments, we propose you to hold them for the remaining 15 minutes. If there are questions, comments, if not, Helene, Rim, if you are ready, you can start. You have the scene.
Well, thank you, Anna. Thank you for giving us the opportunity to present our work. I'm an INRAE researcher at the CESAER laboratory in Dijon, and Rim is a PhD student at the GAEL. Our work is a joint work with Sandrine Maty and Carol Trebisch. And as Anna said before, we are going to speak about transport mode, health, and pollution. So the outline of the presentation is very standard, but we will spend a little more time than usual on the introduction to present the context and the motivation of this work, and in particular the Mobil'Air project. The basic observation is one we all know. The cities in which most of us live are heavily polluted. And in orange, we can see three examples of European cities, Grenoble, Barcelona, and Paris, which are above the World Health Organization's threshold of 10 microgram of PM2.5, that's fine particles. So above the threshold of 10 microgram per cubic meter. We can draw a similar diagram for the city in which are the laboratories of the suite seminar. And here are the PM2.5 concentrations of 1 hour ago, about at 3 p.m. Today. And we can see that most values are also above the 10 threshold, for example, in Annecy, in Nantes, Grenoble, Paris, and so on. This pollution can be expressed not only in terms of concentration, but also in terms of health impact. For example, in Grenoble, some of our colleagues have shown that every year, 145 deaths are attributable to fine particle pollution. We estimated the associated cost at almost 500 million euros per year only for the Grenoble conurbation. In light of this, a research project called Mobil'Air emerged. It's coordinated by Sandrine Maty, and with an interdisciplinary approach, this project aims to identify precise measures and actions to significantly reduce atmospheric pollution in cities and the impacts of this pollution. This project has three main objectives, and the first objective was to better characterize the pollution's exposure, the population exposure to air pollution. We focus here on fine ambient particles, and the standard metric is the mass of the particles. But our colleagues, chemists and epidemiologists, proposed a new metric to characterize the health impact of pollution. It is the oxidative potential, and the oxidative potential is the ability of particles to create oxidative stress in the lung, and that is what leads to respiratory disease. They found that change in the metrics also change the two main contributors of pollution. It is heating, hood heating, and the traffic road, which are the most two oxidizing sources for the lungs. It is therefore on these two levers, heating and road traffic, that public policies must focus. That leads us to our second objective, and it's to provide public policy scenarios to reduce air pollution. And instead of starting from pollution reduction actions and assessing the health and economic impact of these measures, the modeling was done in the other direction. So we first asked the local stakeholders in the Grenoble metropole to choose a health objective, and the actions, the measures, were then derived from this objective. More specifically, the local elected officials have chosen the most ambitious health objectives that we proposed to them. And since they have chosen a decrease by 66% of the mortality attributed to air pollution in 2030, compared to 2016, which is our reference year. This takes into account the tendential evolution of air pollution. That represents 95 avoided deaths per year. And from this objective, the epidemiologists calculated what it means in terms of reduction in population exposure to the pollution. And then it was possible to derive the reduction of pollutants emissions to be achieved. The regional atmosphere organization, Atmo Auvergne-Rhône-Alpes, modeled how to achieve this concentration by moving the sliders on two sources, hood heating and car traffic. One extreme possibility is to completely stop traffic emissions and to allow some wood heating emissions, and the contrary is also possible. An intermediate solution here is to reduce an intermediate solution is to reach the 66% diminution of pollution with the replacement of all inefficient wood heating facilities and a significant reduction of car traffic. It's possible with technological solutions, but also with the use of less pollutant cars and by reducing the car access to the center of Grenoble with an ambitious low emission zone. And it's also necessary to reduce by 36% the vehicles kilometers with motorized mode in the conurbation of Grenoble. That means a modal shift from car or motorcycle to soft modes such as public transport, cycling, or walking. Such actions lead to consequent benefits. It will be possible to avoid up to 270 deaths. And cost-benefit analysis also lead to a 9 billion euro benefit per year. And the leverage effect is almost 6. That means that for one invested euro, for instance, in public transport or cycling infrastructures, the benefit is 5.8 euro times higher. Maybe some of you are going to ask, you said we want to reach 95 avoided deaths, and now you are speaking about 272 avoided deaths. That's because reducing car traffic also has significant co-benefits, which are represented in this figure. We have taken into account all co-benefits or negative impacts of car reductions, or at least everything we have thought of. So we have taken into account diminution of pollution, but also potential increase of accidents. And we also have taken into account the health impact of increasing physical activity for people who cycle, walk, or take public transport. Because even when using public transport, people walk to reach the bus or the train station, and they walk more than when they drive their car. As a result, 93 deaths could be avoided with a decrease in PM2.5 concentration, and 179 additional deaths could be avoided thanks to the increase in physical activity. Here you have three graphics because we have constructed three different sub-scenarios for modal shift. One in which people mainly shift from the car to public transport, one in which they mainly shift from the car to active modes, and one in which we introduce also the e-bike, that's the vélo assistance électrique, which significantly increase the proportion of the population who use active modes and therefore engage in physical activity. That leads us to the second lesson of the Mobil'Air project, and that we will use in the paper with Rejeb, Carol, and Sandrine. It is that health benefits of fighting pollution with a modal shift to soft modes are related to decreased pollution, but also to the increased physical activity. Now the question is how to reduce the use of private cars. This question is very important because the modal share of private car is still very important in France. Here is the modal share in 2017 for the Swiss cities. And we see that they are above 50% for many cities. But it's much lower than what we observe in general in France, because it's the center of its cities, it's the center of the cities. I didn't take the urban area, and that's why it's quite low compared to what we observe in France in general. So the next question is how to induce a modal shift to public transport, cycling, walking. And that's a third objective of the Mobil'Air project. There is a very large body of literature addressing this issue, and it's far beyond this presentation. But what we can remember for the rest of the presentation is that the choice of a mode of transport is multifactorial. It depends on some individual variables such as age or gender, but also it depends on the characteristic of the transport mode, for instance, travel time or travel cost. But what we did not find in the literature, except maybe one or two references, is how the health-related characteristics of the transport modes impact mode choice. There is a gap in the literature, and we are going to study this in this paper. To address this question, we will first consider the choice of alternative modes as a pro-environmental behavioral decision. And it has an impact on public health, such as eating organic products or sorting waste. Air quality, as water or soil quality, is a public good, and the preservation of this quality requires a collective action, that everyone participates in the collective effort by limiting their car travel. But in the same time, whatever your effort, it will not influence directly your own exposition to the pollution, hence the free riding problem. For altruistic people, the health impact through pollution may influence their mode choice, but it's not enough. Otherwise, the car modal share would not exceed 70% in France. But we can also see a modal choice or the shift from a car to a soft mode from another angle, that of individual health and physical activity. The health impact of cycling or walking are not dependent of the action of the others. To our knowledge, there is only one paper interested in the impact of individual health information on transport travel-related choices. Eleonora Sotil and her colleagues consider our CO2 emissions and stress when driving by car, influence travel choices. They found that the latter, that is stress, have the greater influence on travel choices. Food is another interesting field to make the link between individual health and consumption choices. Some authors calculated the willingness to pay for organic or natural food. However, all these studies explain the link between food and health, but with dichotomic variables. It is organic or not, it is natural or not, and not with a quantified relationship. They do not explain the health risks in terms of morbidity or mortality. Morbidity is related to diseases. To our knowledge, we are the first one to estimate this relationship, and even in medical studies, we did not find such a relationship. If any of you have references, we will be very glad to hear about it. So our research question is, how does information provided to individuals on the positive and public health impacts induced by active or less polluting modes of transport modify this modal choice? By answering this question, we have three contributions. The first one is to consider the health impacts of mode choice. The second one is to distinguish between public and individual health impacts. And the third one is to quantify the relationship between health impact and the decision, which is a mode choice. I will now let Rim explain you the method and the estimation results. Just keep in mind that it is a work in progress and that we still have estimations to do, and that all comments are very welcome.
Thank you, Helene. So to respond to the research question presented by Helene, we use it, next slide, please, Helene. Yes, so we use it original data. So we used original data collected through an online stated preference survey with a discrete choice experiment that we conducted from June to September 2019, with a sample of 1,000 participants from the Grenoble metropolitan area, of course, in France. So in the discrete choice experiment, we put our participants in hypothetical situations called choice exercises, where we ask them to choose between different options of transportation modes, and we ask them to make this choice to make a personalized trip declared as a regular trip. For example, a participant could declare going from home to work every day as a regular trip, or going to the university. If the declared trip is of a distance below 3 kilometers, we propose 4 modes of transport: the car, the public transport, the bicycle, and walking. But if the participant declares a distance above 3 kilometers, we only present 3 options by omitting the walking option. We also ask our subjects to make their choices considering their reference mode, or what we call their status quo, which is the mode they usually use to do their declared reference trip. Each participant go through 9 choice exercises that we divided into 2 steps. In the first step, the alternatives are described with 2 attributes: the time and the cost, as we can see here in the example screenshot. Next slide, please. Okay. And in the second step, for the remaining 7 choice exercises, we introduce 2 health-related attributes which constitute the originality of our design. The first health-related attribute is the impact of physical activity on the individual health, described as a reduction of the risk of developing a cardiovascular disease. And to make sure that our participant understood this health attribute and these risk probabilities, we used smileys. We informed them that in France, in average, an adult faces a risk of 30% for developing cardiovascular disease during his lifetime, and this risk is visualized using the red-faced smileys. If the individual decides to practice physical activity for a minimum of 30 minutes on a regular basis, the 30% risk is reduced to 24% as an example in the screenshot that I'm showing you here on the slide. This risk reduction is described using the green-faced smileys, referring to healthier individuals. Next slide, please. And then next slide, please. Yeah. So regarding the second health attribute, the previous slide. Yeah. So regarding the second health attribute, we present the impact of the mode of transport on public health, described also as a risk of developing a cardiovascular disease. Similarly to the previous health attribute, we start with an average risk of 30%. And if a certain share of the population decide to adopt a less polluting mode, this risk is reduced. In the example screenshot, there is a proportion of 90% of the population who adopt an alternative mode to the car, which reduces the risk from 30% to 27%. And we visualize this through the green-faced smileys for healthier individuals. For this health attribute, we suspected a conformity effect that may emerge here. So to test that, we varied the information about the percentage of the population already using alternative modes with either 50%, 75%, or 90% of the population already adopting alternative modes. Next slide, please.
Sorry, Reem.
Yeah.
Probably it is better to start your own presentation. And in the meanwhile, we have a question from Stefan.
Yeah, sure.
Like that.
So Helene, could you please stop the sharing so I could share my screen?
So we have a question from Stefan. Helene. Mm-hmm. I can address it to you. Are there any identified costs to reducing personal vehicle use, time, comfort? And how are they taken into account in the study or not?
Can you repeat this? I had some problem with my microphone, but now it's okay.
So are there any identified costs to reducing personal vehicle use, such as time, comfort? And how are they taken into account in the study? The question is in the section.
I'm just
or if it is, we can keep it at the end. Stefan, I hope it is okay.
excuse me, I have some problem with my audio.
We'll keep the question
maybe
for the end.
Write the question.
It is on the.
It's okay. Now it's okay. I have the question. I have only the question from Marion Leroutier.
Yes, this one just appeared right now.
I can answer this question, and maybe you can post the other one because I don't see it. I'm sorry.
I propose to keep the other one for the end of the seminar and to answer to the question of Marion.
I can answer the question from Marion. Yes, okay. Yes, we to have the decrease of risk from 30 to 27%, we made quite rough hypothesis, and we based our estimation on about 75 decrease. That's about 75 of the population use an active mode of transport. We didn't link in the level of the attributes that we propose to people. We didn't make a direct relationship between the share of the populations that use soft modes and the levels of attributes, because we wanted to see only the independent influence of this percentage of population using alternative modes of transport. So what you can retain is that we based these values 25, 26, 28% on real response dose relationships, but not in a very precise way, in order to disentangle the effects of the different variables, including this nudge effect of 90, 75, and 50%. I don't know if I'm clear. But
we hope so. Thank you, Helene.
Okay, so I continue the presentation. So as almost what Helene just said, so the levels of the presented health attributes are alternative specific. So we have different levels for each mode when going through the choice exercises, and they also depend on the distance of the regular trip declared by the individual. So whether it is above or below 3 kilometers. This is always also true for the time and the cost attributes, but I just wanted to focus on the health attributes for this point. Here is an example screenshot of one of the 7 choice exercises of the step 2 of the discrete choice experiment, where we have the different transportation choices available, and we have the attributes that describe them, so the time, the cost, and the 2 health attributes. Moving on to the modeling framework, we model the utility function of each transportation mode using the standard discrete choice modeling formulation of McFadden, where the utility function takes into consideration the previously presented attribute. So we have the estimated effect of the the time, beta time. We have the cost, the individual health attribute through physical activity, beta phase, and the public health attribute through air pollution, taking into account the framing information about the share of the population, 50, 75, or 90%. And of course, we control for the effect of some individual characteristics that are the age and the gender and the status quo of the participants. Now I let Helene explain one more idea in the model framework. Yes, Helene.
Okay, so in the utility function presented by Rejeb, we introduce the probabilities of cardiovascular diseases. And one question is, how do people perceive these probabilities? Are they overestimated or are they underestimated? And to reveal such a transformation, we use the power function. Other function could have been proposed, but we will try this later. And in this specification, the risk is expressed as the difference between the probability of developing a cardiovascular disease by car and the risk when using an alternative mode of transport G, either public transport or cycling. Here is the expression, so you can see the expression with physical activity, but it's the same with pollution. With this specification, if delta equal 1, then the risk difference between car and another mode of transport is perceived as it is presented. But if delta is lower than 1, for instance 0.5, then the risk difference is underestimated. That's the purple line. And if delta is higher than 1, for instance 1.1, then the risk difference is overestimated. That's the red line. So go on, Rejeb.
Okay. So using the utility, the same utility formulation, we adopted two modeling structures. We have the multinomial logit models and mixed logit models. The main purpose is relatively the same, since we always try to evaluate the extent to which the provision of information about the individual and public health impacts of mode choice could influence the transportation behavior. The only difference is the way we introduce the parameters related to the health attributes in the utility function. In the first model, so the multinomial logit model MNL1, the parameters related to the information about health risk are assumed to be fixed, which implies that the model is homoscedastic across individuals. The modified version of the multinomial logit model, so where we introduce the delta that Helene just explained in the previous model, we have the same intuition as the MNL1 model, but we consider here the individual's perceptions of risk variation. Then we implemented more complex modeling specification to relax some limitations of the multinomial logit model. So we used a mixed logit model, specifically a random coefficient model that we call ML2, which allow us to gain more generality and test whether we have or not a presence of heterogeneity in the participants' behavior in regards to information about health risks. To do that, the coefficients of the two health attributes are no longer assumed to be fixed, as it is the case in the multinomial logit models, but they are assumed to vary across participants, so they are random. In that manner, the coefficients are defined with two elements, a mean and a standard deviation. If you find a significant standard deviation of the estimated parameter, this accommodates the presence of preference heterogeneity in the sampled population, and this is often unobserved heterogeneity. We assume in our case that these random coefficients are normally distributed, so we make a behavior a priori assumption that there exist both positive and negative values for the estimated effect of the health attributes. So for the presentation of the estimation results, I wanted to give you a small idea about some characteristics of our sample. By looking to the descriptive statistics, we see that the majority of our participants are usual car users, with a share of almost 54% of our sample. We also have a majority of individuals who make regular trips with distances above 3 kilometers. Now for the estimation results, using the model specification that I presented earlier, we make different regressions depending on the reference distance, so above 3 kilometers or below 3 kilometers. So the participants whether sees 3 options or 4 options in his choice exercises. For today, I will be presenting in detail only the estimation results for the classical multinomial logic model, so MNL1, and the mixed logic model, ML2, and I will leave the presentation of the results for the modified multinomial logic model, where we introduce the delta, since we both multinomial logic model have the same basic intuition, but so I didn't want to repeat the results in the table. However, we will present later on the economic outputs for the 3 types of models, which I think would be more explicit and interesting economically speaking. For the interpretations of this table, we choose the car as a reference mode. So the first result is a classical result in discrete choice models, since we find a negative and significant effect of the cost on the individual preferences for all the models. This means that an alternative with higher cost is less likely to be chosen. Regarding the effect of the time attribute, on transportation choices, we find a significant effect only for walking when distances are below 3 kilometers, which could be explained by the fact that we talk here about short trips, so the duration is negligible when done with modes other than walking. For distances above 3 kilometers, the time attribute influences the choice of the 3 available modes, with a less negative perception of time in the car compared to public transport, and even less when we compare to the bicycle. Since we focus in the study on the effect of the health attributes on mode choice, I will present the effect of these health attributes in more details in the next slide. But just to finish the presentation of this table, I wanted to mention the effect of the statu quo on the individual utilities. We actually find a positive and significant effect for all the models, which means that individuals with a statu quo different from the car always prefer to choose alternative modes to the car. In regards to the effect of the health attributes on transportation choices, first we find for distances below 3 kilometers that information about the impact of mode choice on individual health, so what is colored in red, this type of information don't have a significant effect on transportation preferences. This is true regardless of the model type. This could be related to the fact that our participants consider that for such short trips, physical activity is not intense enough to influence remarkably their health risk, but information about the positive impact of reduced air pollution on public health, so what is in green, this type of information seem to significantly influence transportation choices. These effects are different depending on the framing information about the share of the population already adopting an alternative mode to the car. And we actually find that this type of information is significant and has larger effect when the framing is with smaller shares, so 50% for the multinomial logic model, MNL1, and 50 to 75% for the mixed logic model, ML2. final point for the interpretations with distances below 3 kilometers, we see that for the multinomial logit model, ML2, where we test whether we have unobserved heterogeneity in the preferences, we find a significant standard deviation only for the coefficient of the health attribute related to reduced air pollution, with a framing of 75% of the population. And what this means is that 25% of the participants who were framed at that level have a different sign than the mean coefficient, so a positive sign in this case, and it refers to individuals who continue to prefer the car even though the alternative modes present a lower public health risk. Looking to the results when the distances of the reference trips are above 3 kilometers, both types of health risk information have a significant effect on the transportation choices, encouraging the use of alternatives to the car. This is true for both models, except in the case of information about the positive impact of reduced air pollution on public health, with a framing of 50%. So in the multinomial logit model MNL1, otherwise the effect of the information about public health is greater when the share of the population is already adopting an alternative mode is larger, so we seem to have a conformity effect. With these longer trips, we no longer have heterogeneity in the preferences of the participants in regards of information about public health. But for information, when we look for the effects of information about the individual health, we find first that it encourages the use of alternatives to the car, and we notice some unobserved heterogeneity referring to 29% of the participants making longer trips that have a positive coefficient for this attribute. So they continue to prefer the car even though the alternative modes present lower individual health risks. An interesting feature of discrete choice models is the possibility to calculate willingness to pay for each attribute involved in a discrete choice experiment, which allows to give each attribute a monetary value. As a reminder, we define willingness to pay as the variation of the cost attribute that an individual would accept to maintain the same level of utility when there is a variation in another attribute. And here, as an example, I put the formula to calculate one type of willingness to pay, which is the value of time, giving the willingness to pay to get time reduction in the duration of a trip. And now I let Helene present what we find as economic outputs in our case.
So we'll go to the next one because we don't have enough. We don't have enough time. So you can just keep in mind that the values of time are consistent with the literature. What is more interesting for us is the willingness to pay for risk reduction. So for air pollution, the three blue lines, that's the health risk related to air pollution. We propose risk reductions between 1 and 5 points. And for risk related to physical activity, we proposed risk reduction between 2 and 15 points. If we focus, for instance, on a risk reduction of 2 points, that means if you, an average adult, use public transport instead of your car, then your risk of developing a cardiovascular disease is 28% instead of 30%. To reach such an impact, we make the hypothesis that this behavior is repeated every day and not only one day, and not only one day and for one trip, but every trip you make. For physical activity, the calculation has been made with, so as I said before, with dose response function using metabolic equivalent task and travel time. If we suppose that 50% of the population adopt this behavior of using an alternative mode to the car, it's just, I'm still at the slide before. Then the willingness to pay, it's the bottom line in dark blue. Then the willingness to pay is 0.81 euro per trip for the pollution attribute. And if 75 or 90% of the population adopts this behavior, then the willingness to pay is significantly larger. Concerning the physical activities at the green line, the willingness to pay is 0.86 euro per trip. And this means that it's higher than for the pollution attribute, but only if no more than half of the population use alternative modes of transport. Maybe just next slide. We find the same results if we focus on a higher risk reduction. I will not develop, but what we can just say is that even though the willingness to pay is increasing with the amount of risk reduction, the function is concave and the marginal effect of an additional point of reduction is very, very low. This means that the reduction itself has an impact on choices, but the amount of the reduction is underestimated. As a conclusion, what we did learn to answer our research question, first, both public and private health impacts have effects on the intention to use alternative transport modes. Second, there is a large fixed effect of health impact influence on mode choice. And third, the nudge effect of providing the information on which percent of the population adopt a behavior has a strong influence. So that means that the communication must be carried out for both on both pollution and physical activity. Yes. And what is next in our work? As Rim said, with the mixed logic model, we revealed a high heterogeneity in preferences. And so we would like to to go a little further and to estimate a latent class model with some classes in which people do not value one or the other or both health attributes, and other classes where people value all health attributes. As a final conclusion, we are well aware that discrete choice experiments have many drawbacks, and that they do not reveal real behaviors of people, but only intention to change behavior. That's why in the Mobil'Air project, we are going one step further, and a field experiment with a random control trial is going to be launched in September 2021 to study how to effectively get people to change their mode of transport.
Thank you.
And maybe I can answer the question of Stefan that I didn't hear just before. It's about the costs we take into account, for example, financial cost or comfort. In this study, we take into account the financial cost and the temporal cost, that's the time that is included in the utility function. Other costs such as comfort are not taken into account here, but we studied it in other works. The difficulty is that it's mode choice is a multi-parametric choice, and we cannot take everything into account in a single discrete choice experiment.
Okay. Thank you, Helene. Thank you, Rim, for your presentation. So you started the question time session. I will continue with, I will read you a remark from, and the question from the part of Adrian. First of all, Adrian is saying that the definition of the willingness to pay looks like the definition of an equivalent variation, constant utility. Do you want to develop on that, Rim? Or
if I understood clearly his question, yeah, it's the same. It's the same thing. So we try to see how much money the individual is willing to pay as an additional amount, so he can maintain his utility constant. So I think that's what he's referring to, equivalent variation.
And equally from the part of Adrian, did you consider the increased risk of road accidents for bicycles? Because a person concerned with health risk may also consider that risk when making a decision.
It depends on the study. In the discrete choice experiment, we didn't consider the increased risk for accident. But in the first study I showed at the beginning, here we calculated the health impact of decreasing car use. And in this one, we considered accidents.
We have also a question from the part of Silvana. When you take a bike, you breathe all the emissions of cars around. So how you take into account that bike reduces the risk of cardiovascular disease?
When you take a bike, you indeed breathe the emissions of the cars around. But when you are in your car, you also breathe the same emissions. And sometimes it's even higher because you are in the car and you have cars all around. While when you are cycling, you are a little not so, you are a little far, not far away, but not so close.
The bicycle line, where?
Yes, with the bicycle lines and so on. And so this is taken into account. And if you make the addition between what you breathe and the physical activity, the sum is positive.
Thank you. Another question from Marion. How representative is your sample compared to Grenoble population? Did you test the homogeneity of your results based on declared health status?
For the first question, we recruited the participants following quotas. The quotas were calculated depending on the characteristics of the Grenoble metropolitan area. So I think that our sample is more or less representative of the Grenoble population. And for the second question, did you test heterogeneity for the results based on declared health status? Declared health status. Yeah, we didn't do that.
Oh.
We didn't do that, but we
No.
have the information in our questionnaire, since we asked our participants whether they felt.
We have questions about the health as it is perceived with a health questionnaire, but for now we didn't test the link between the answers and this indicator.
Another question from the part of Martin. Do you think your results are framed by the fact that Grenoble is known to be polluting?
Yes, it's possible. It would be interesting to do the same study in another city. But it's true that Grenoble is known to be polluted, but when you look at the average pollution for PM2.5, But for example, Lyon is far more polluted than Grenoble. So it's not the most terrible city in France, by far.
And Ghislaine is asking you if you think that the answers would have been different in winter.
It shows that the people, the weather is important to explain mode choice. And if you ask this type of question one day, if it's raining or if it's snowing, people won't have the same answer. But here we try to have a speech before the discrete choice experiment, explaining people that it's a mean day and that the weather is okay to walk or to cycle.
I don't see, thank you. I don't see any other questions. Federico, probably, or you can open the discussion. Are there any other questions? From Martin, your benefits are underestimated because of altruistic effects. Maybe underestimated.
Do you mean because people want to be nice with the interviewers?
Probably.
It was a web survey, so there is no bias linked to the interviewers. I don't know if it's a question or not.
Yeah.
Yes.
Yeah, go ahead, Helene. Go ahead, Helene. No, I wanted to say that that was one of the motivations behind our question. That's why we divide two types of informations, one related to public health, so more altruistic, and one related to the individual health, which we consider as more, not altruistic, egoistic. And we wanted to see whether this differentiation is going to influence differently the choices of the individuals. So that's what I don't know if I answered your question. But the underestimation, I don't understand what underestimation are you referring to? About the delta, about the risk variation? If you could maybe clarify your, yeah.
Frederic,
yes,
can you
perfect.
open, it is possible to open the microphone for Martin?
Yes, excuse me. Do you hear me?
Yeah.
Yes.
Yeah, it just, actually, with some colleagues, we are conducting description experiment, trying to value both safety benefits. And one of reviewers said, okay, you claim you are estimating individual benefits from reduced risk accidents, but if I die, my relatives will be harmed. There are some psychological costs because I'm dead. So if I'm not dead, I save my life, but I also save some benefits for my relatives because of these psychological effects. And I think you are here, you are facing the same type of external effects in the sense that you have your own house benefits, but when you switch from cars to bikes, it's good for you, but it's good also for the rest of the people. So again, it's the same altruist versus egoistic point of view, but it's just to say if you are under, or maybe the reviewer are asking you, are you over or underestimating the health benefits? And this may be useful or not at all. Sorry.
Just about the psychological effects, we didn't take them into account in this study, but in the second objective of the Mobil'Air project, when I spoke about the cost-benefit analysis and on the reverse modeling. In this cost-benefit analysis, we have taken into account these psychological effects.
Okay, thank you.
So I think that there are no questions anymore. We thank you all for listening and participating.
Thank you.
And Rim, thank you again for your insightful presentation on transport modes and choices. Thank you all.
Thank you, everyone.
Evening. Have a nice evening.
Okay, thank you for everybody and for this very nice presentation, and in fact with some very huge job beyond the paper, I guess. Also, next time, this will be in 2 weeks. I don't know who will present, but next suite seminar will be Tuesday in 2 weeks. Have a good afternoon. Bye-bye.
Thank you. Goodbye.
Thank you.
Mhm.
Bye.